All right. Okay. Hi, everyone. So what I want to do today is keep talking about multi-file programs and also contexts in which we actually want to use multi-file programs. So it's a situation that's like today's lab, actually a little bit like project one, where what you're doing is you're creating a situation where you have functions that could potentially be used in multiple contexts, and you're dumping them all in one file, and then you have another file that's using those functions. So a classical situation for this kind of thing is something like when you're declaring a string structure. So something that you could potentially use in multiple contexts. So it makes sense to separate it out into one file and then use it in another file. So to remind people what we're doing with strings, so I'll just do it in the simpler context of string just for a second, and then we'll switch back to the integers, which are more complicated. So what we had was we said a string is going to be the address where we store the string. So that would be str. And we'll also keep track of the current length of the string. And then I'll create those functions which allow me to operate on my string. So far we made create and we made destroy. So create is something like when you're creating a string in Python from a literal, for example, you say like, in quotes, "anxi" or something. And then we also made a concatenate. So what concatenate did was take a destination string and a source string and concatenate the source to the destination. So actually, a while ago, I promised a substring, so I'll just do substring as well. And this would be, I'm taking my PS, and then I want the start index and the end index, right? So something like that. So that's declared in mystring.h. So in mystring.c, those names don't have to match, right? So the names of the files are just names, but by convention, they would be the same. And I'll make the substring. So, okay, so what do I need to do in substring? So first of all, just like in Python, you're doing a slicing thing. You are actually creating a new string. So the first thing I want to do is I want to actually create a new string. So to remind you, this is create. So create takes a pointer to create takes a pointer to string, and then it allocates that, right? So here there is a little bit of a problem. So if I say my string new string, and then I create it like this, what's the problem here? Anyone? Yeah. So the problem is that if I return new string, well, of course, like here it's not even returned, then it's fine. But usually I want to make it void, like everything else is void. And in this case, I cannot return, so I cannot modify a string. because this is a local variable. So the best I can do is I can return it. So we'll do it like this now. And that means that this will need to actually return my string. So we'll switch the definition here as well. And that's fine. So I make this local variable. When I return it, what I'm doing is I'm going to be copying the contents of the new string, right? So like outside here, what I can say is S is like my string, substring, whatever, right? So this local variable would be destroyed once the function finishes running. However, the return value is just going to get copied over here. So you can do it like. So, all right. Yes.
Doesn't my string code only accept cheap values instead of
that is true. No, it accepts 3. So it takes this, and then it takes this, which we haven't actually done, and then it takes the length. So that actually works. So what's happening here, and that's worth looking at, is I am looking inside of PSSTR, right? So I'm going to the str in the original string, and then I'm saying str plus I. So PSSTR plus I, so it's as if PS str, if that is angst I, and then we're saying like I is 2, j is 5. So PSSTR plus 2, what is that? Well, that's this guy. Does that make sense? So specifically, PSSTR plus 2 is the address of the G. Question. Is everyone good with, is anyone not good with this? Yes. Say it. Why is the J underlined? Because this is it. All right. Other questions? Is this making sense? So we're saying create. So we're saying here's the address of my new string. And inside of create, we're going to say, okay, so make the length be the new length. So j minus I plus 1. And then str we allocate. And then we copy from the original str to our new PSSTR. So in this case, the str would be like this, right? So the str would be, I'm starting at index I over here. So PSSTR plus 2, for example, would be the address of the G. Is that making sense? All right. So here, what's the length really? So here it says j minus I, and in Python notation, it makes sense, right? Because we go from I up to j, but not including j. So that means that the total length would be j minus I. So we can verify it with just an example. So here I is 2, j is 5. So 2, 3, 4, 5, not including 5. So the length of the string would be 3. 5 minus 2. Is that making sense? All right. So that's the substring. So we create it and then we return it. So we can now test this. So this is use my str. So in use my str, what I want to do is, so here, let me run this first. So it seems like there are problems. That should be commented out. And that should be saved. So let's try it again. It's just one problem. But here I neglected the int. I'm going back to use my strc. And that now compiles. And that is saying anxi praxis. So let's say that I just want the praxis point. So how would I do it? So I would say my str substring is my str substring. So the type of substring is pointer to string. So that means that I want to send address of S here. And here, so P is the 7th letter. So we start with 6. And 6, 7, 8, 9, 10, 11, 12. So up to 12, not including 12. And now I want to print it. So why .str? Well, it's because sub is of type myStr, right? So if this were a pointer to myStr, we would do an arrow. But because this is just a struct, right? So it's a variable of type myStr, you access the fields using the dot, right? So to access the str, you just say sub.str. If it had been the case that sub were a pointer, then it would be an arrow, right? So what we've done last time, just to demonstrate, is, well, like if sub were a pointer, so we said address of sub, then we would say, okay, like you do an arrow. Of course, like the address of and the arrow just cancel out each other, so it doesn't make sense to do it in this context, but you could. It's the same thing. Is that making sense? Questions? All right. So let's try to run this. Cool. So here, it seems that it didn't completely work, right? So I wanted 6 to 12, but what happened is I'm still outputting the exclamation points after praxis. So let's see what's going on. So what I'll do is I'll put a breakpoint here, and you'll do it in the lab today as well. And I'll run this. So now I'll step in. So you step in like this. And now I'm in my different file. So here I'm saying my string create. And I'm saying, okay, so I'm sending in the address of the new string, and I'm sending this guy. So we step in. So the length is here. So the length is 6. That seems to make sense. Not null. And now I'm saying strcpy ps str. So does it make sense that what happens is the output after that is praxis 3 exclamation points? Why? Yeah.
Because string copy keeps going until it hits the null terminal.
Yes, so string copy doesn't care about my length, right? String copy just says start with whatever this is, and this is praxis 3 exclamation points, because we just said whatever was the first word, and then just start with the P and go until the null. And what it's doing is it's just copying it element by element. That's really bad, right? So it could crash, because when I said here PSSTR, I actually did give it the length that I intended to give it, right? So this is 6 plus 1. However, it's going to copy until it encounters a null in str. Does that make sense? Yeah. Yeah, so we kind of would have to, right? So like you could kind of hack it by saying, oh, I'll just put a null in location J and str. Of course, that would mess up the original str, so don't want that. So yes, like we would have to actually use a for loop. Or implicitly, we would say memcpy, and we'll copy this much. So we'll copy from str to psstr, and we'll do length bytes of that. Right? So copy to psstr from str, and copy length bytes. So that is copying length characters. It's not copying the null because there is actually no null in the original str. The original str could go beyond J. Right? So one extra thing that we need to do here is to say, okay, so at length, we actually put in the null manual. Is that making sense? So, okay. So we're done. So I can just try again. So I'll remove the breakpoint and I'll run the thing. All right. So it did print praxis now. Yes. Saying it? Well, no, because it says length bytes. So it doesn't, in fact, know the data type. Right? Because when so you can pass any kind of block of memory to it. It won't know what the type of the block is. This is just saying length bytes. So it might be nicer to say size of car. Of course, that's the same because size of car is 1. Make sense? So again, like why was string copy bad? Well, it was because str actually doesn't have a null at location J where we wanted to end the substring. So what we had to do instead was just to say, okay, like move over this many characters because I know that this is how many characters I have, and then put a null in the destination manually. All right. So that's like that. So to remind people, and again, kind of the people who have the lab today are going to do it in the lab as well. So in order to make this work with multiple files, you have to actually go here. So I've already done that. So if you do it the second time, it'll just make a default thing again, and VS Code just takes the last thing. But what we've done before is I said, I want to compile this guy and I want to compile this guy. So one thing you could do is you could say, okay, I'm just going to make a different version, a different implementation of string. Right? So I'll save it as my string 2 or something. And in here, I'll do what you suggested. So instead of using memcpy, not a big change, I'll just do a for loop. I'm busy. So you can do a for loop like this as well. You don't have to declare int I separately. So here we'll just do whatever, copy it like this, and then set the null. So what they can do is they can choose to either use the mystr2 implementation or the mystr implementation. And I'll just say over here, instead of saying mystr.c, I'll say mystr2.c. So this way, in this case, it's not a big difference. I just swap the for loop instead of the memcpy, so not a big change. But this is in principle powerful because you could say, I'll just do a different implementation, possibly a completely different algorithm, and then I'll just compile it again with the use staying the same, just the implementation being different. And that's because the declaration is separate in mystr.h. And then the implementation is like in either mystr2c or mystr.c. I can just swap those out and compile one or the other. Does that make sense? So in this case, we still haven't gotten to a situation where we can have kind of alternative algorithms for the same thing, but we will in the coming weeks. And then it's going to become, well, you can use this or you can use that. In different scenarios, it might be that you want to compile with different C files. Separately, kind of when we are auto-grading your project, what we do is the same kind of thing, right? So we compile our tester code with your autocomplete.c, and we can swap, well, your autocomplete.c for yours and see which one works better. Of course, as long as they're correct, like they both will get 4 marks, but we could. Does that make sense? Questions? All right. So that's like that. So in order to be able to trace your code, so to put in breakpoints and stuff, you have to set things up in tasks.json. So again, kind of terminal and then configure tasks, or you can just manually go into tasks.json in your folder. So in the lab, we're going to make you do it and make you demonstrate to the TA that you can actually trace your code. And that's because like tracing your code is like much more efficient when you're debugging than trying to do things with printfs. You can, like you saw, also do it with GCC. So with GCC, you would say GCC and then use mystring.c and then mystring2.c. And that would be like this. Or you can do things like this. And that would produce different programs. So I can say that the program here would be called like out2exe, I suppose. And then the program here would be called just out.exe. And then I can run out2.exe. And I can run out.exe. Those are, of course, the same, assuming that mystring2 and mystring do the same thing, just slightly differently. But I think kind of sometimes you're tempted to just do GCC rather than set up tasks.json. So in the lab, we're like specifically saying you're not allowed to do this. Please don't be tempted because that makes you not be able to debug, and that's bad. All right. So one more thing that I wanted to bring up before we switch back to implementing integers. So here I made things like this. So I kind of said, okay, like I sometimes am going to define the variable here. So I'm going to say sub is just of type mystring. And sometimes I'm going to pass a pointer to mystring. So that's okay. And people do that. I did that. However, the thing that's the more usual thing and the thing that you see in Python is everything is an address. So you can just adjust things and do it that way. So I'll call it my string P. And the way you would set it up is you would just say, okay, I want to always be passing an address. So if I'm always passing an address, that means that here I want to be able to actually set an address that I'm passing to something new because I'm creating a new object. So similarly here, I might like to just create a pointer and then set that pointer to something. So I'll do it like this. So then let me open up my string str and save it as my string p. So I'll just adjust it like this. And here I'm passing a pointer and I want to create the whole thing from scratch. So that would mean that I want to say PS is a new my string. All right. So I'm passing the address of a pointer, and then I'm saying set that pointer to something that I've allocated. At that point, I'll just start using star PS instead of PS. So you might say, why isn't it PPS? And that's because in my new style, everything is a pointer. So if I make it PPS, like I'm just gonna have like a P in front of an extra P in front of everything. And if there is never an S, then it doesn't really make sense. So I'll do it like this. So that's one way of doing it. Now, this involves copying a bunch of stuff. So I have a star PS kind of all over the place. So one thing that I might like to do is I might like to just say, okay, so actually let's keep it like this. Right. So now when I call it, what's going to happen is I'm going to define a string over here. And I'm going to pass the address of the pointer to string to my string create. Right. So whereas before what we had was I'm defining a local variable here and I'm passing the address of the local variable. Here I'm saying I'll define a pointer to my string. So initially S is just a random thing. It seems like an address, but it's not an address of anything in particular. And inside of my create, what happens is my create makes S be the address of the string that I'm creating. Right? Because I'm saying star PS, meaning S equals to this guy. Is that making sense? Questions? So that's just an alternative way of setting things up. So what I'm saying is I'll only ever define pointers to strings. I'll never actually define a string as a local variable. And then when I create the string, I'll just allocate space to store my string, which means I'll allocate space to store the pointer to the character block and the length. So one reason to do this is I never have this kind of asymmetry of sometimes it's a pointer, sometimes it's not a pointer. I just make it always be a pointer. But it could work either way. So the advantage here is, okay, so this is like this. And then here, I don't have to sometimes return, sometimes not return. So here, I'll just pass a pointer to a pointer. And for example, in my string substring, now it's like this. And here, I'll just pass PS. Like so. So this is a situation where kind of the dimensional analysis things from physics as applied to pointers can make sense, right? So should it be PS or star PS or what? Well, what I can do is I can go to my string create and say, what's the type of variable that my string create takes? Well, it takes a pointer to my string. What is the type of PS? Pointer to my string. So I just pass PS because that's the type. VS Code is also going to complain to you usually if the type doesn't match. Yes.
If you're still returning variable.
Yeah, that's a void. So in DH, I changed it, and here I still didn't.
Oh, because I was wondering why you found the double formulas if you're still gonna.
Say?
Because I was wondering why you were using double.
Yeah. So I changed it to a void here. I just forgot to change it to a void here. So one other thing that you need to change now is in destroy, you need to free this guy. So once we free this guy, we also need to free PS. On the other hand, don't really need this because because PS is already destroyed. So the difference is that before, when we were defining S, this S cannot be destroyed. It wasn't created using malloc. It cannot be destroyed using free. What we're doing now, on the other hand, is we are making a pointer. So the S itself cannot be destroyed, but the address S, when it stores something that was malloc, should be freed at the end. Is that making sense? Questions? Is that not making sense? Yeah. All right. It's general discontent. So the big picture here, so I'm not trying to kind of communicate rules here. It's more about just following the logic, right? And the logic was, one way to set it up is so that when I set up a new string, what I do is I first declare an address that's not an address of anything in particular, and then I pass the pointer to that so that my string create can set S to be the address of a string, right? The alternative way that we saw last week was to say, I'm creating a concrete thing. So S already has a random length and a random pointer to the character buffer, right? And then what myStringCreate does is it sets the length to something specific and it allocates the buffer, but there is already space inside S to store the length. On the other hand, when you are doing this, initially there is no space to store the length and character star string. All there is one variable that stores an address of nothing in particular. It will in the future store the address of a structure that has the length and the pointer to car. When I destroy it, what's going to happen is I need to destroy both this thing, which was mallocked, and also this thing, which was also mallocked. Before, what was mallocked was the string, but not this. Is that making sense? Yeah.
Oh, you don't need to include these last two lines of code because you're not going to be referencing chaos at all.
That's correct. So I'm not it's not that I shouldn't, it's that I can't. So I could include them before free PS. After free PS, I'm not allowed to access PS anyways. Make sense?
So just that
Shouldn't it be pointer to PS? Yes, thank you. So not the pointer, the other way. All right. So that is how this was set up in the solutions for the midterm, but you could do it either way. All right. Questions about this? So okay. So let's come back and do the integers from scratch. So I'll close the folder and I'll open the integer folder. So to remind you, what's happening with the integers is I have my create integer, I have my destroy integer, I have my set integer, I have print integer and integer. The idea here is that I want the integers to be variable length, and I want to do that in the same way that I did strings, right? So that means I'll just store a block of digits. So I'll change this to a pointer to a pointer. Like so, so that this is also a pointer to a pointer. Here, what is this? So this is from Friday. Right. So what we're doing here is we are creating a buffer. So here PyInt has, why is it not happy? So here that's because it still doesn't know that they changed PyInt.c. So PyInt has a block of digits and it has a length. When we're creating it, we're saying malloc enough space to store the block of digits and the length. So we allocate the block of digits, we set the length, and we set all the digits initially to 0. So what we've done at the end of Friday was to say, okay, if the value is 190, then what we want to do is we want the buffer to be 091 because we want to store the digits in reverse order. And what we're doing is we're saying, okay, so we start with some value. And we don't really need the if here. And we'll set the first digit to 0. So this is value mod 10. So the last digit is 0. So the first digit in the buffer is going to be 0. And then we'll divide value by 10. So value will become 19. And then we do value mod 10 again. So that's going to be the 9. And we'll put 9 in the buffer. And then we'll do value mod 10 again. So we'll add the 1 to the buffer. And then value divided by 10. So value will have become 0. So we're done. Make sense? So, okay. So let's now use this. So I'll say include pyint.h. And I'll include stdio. So pyint p. Now I'll create the pyint. And let's say that I want whatever 3 digits. And now I want to send the pyint to 190. So when I run it the first time, I need to set tasks.json. So I'll go to the Explorer. I actually need to do add configuration. Oops. That's not what I want. So GCC. And here I'll say file their name and then pyint.c. And I'll have file their name use pyint.c. So at this point, I can try to compile. Okay, it compiled, it ran. It wasn't even supposed to output anything. I'll just put a breakpoint here. And now I can see what's in P. So the buffer here is 0. It's supposed to be because it's supposed to be 091. So I can add a watch here to just see what the values are. So I'll say, what's the value of P buffer 0? And add 0. So plus P buffer 1. And that's 1. That's not supposed to be. And this is P buffer 2. So that's 0, again, not supposed to be. So let's see what's going wrong with create pi int. Put the breakpoint here. So we're over here. Oh, actually, I need to step up. Oh, sorry. So what was wrong is I didn't yet set it. So what I'll do is just print high here so that I can put a breakpoint over here. And now I'll run it. And now indeed, p buffer 0 is 0, p buffer 1 is 9, p buffer 2 is 1. So that's working. So to look at those, you can add kind of any expression that you want to keep track of what's going on. All right. So the first, I think it was like question 5A on the midterm was do a plus thing. So do an add 1 to the integer. I think that's like the easiest thing. So we'll at least start with that and we'll continue on Thursday. So I'll add so that just add 1. So that's like easier than add pi int. In fact, if you look at question 5, I think it was 5 on last year's midterm. One thing people could do is just do plus, and then you do add. That's just like a loop where you do plus n times. I don't think there is time for this today, but on Thursday we'll resume. I will see you in the lab. Bye.